Okay, today we're talking about the Axelar Network. In this study, we'll talk about the solution that is trying to bridge many blockchains together. Before now, many blockchains exist in isolation. So we have the likes of Bitcoin, Ethereum, Monero, and a host of other networks. Those that support smart contract and those that don't support smart contract. And as you will understand, imagine Bitcoin is a city, Ethereum is a city, Monero and all these blockchains are cities. If there is no way to bridge these cities together, it becomes a very big problem. So Axelar Network is actually trying to bring interoperability into the blockchain space, and the team are very capable of what they're doing. So let's talk about some of the solutions that are already there. We have talked about the centralized solutions, of which we have the likes of exchanges, house, and the rest of them. We have the likes of Binance. They can easily list any kind of token. That means, for example, you have BTC, you can swap BTC for any kind of token, and the rest of them. And then we'll have interoperability hubs. We'll have the likes of Cosmos, IBC, you have the likes of Avalanche using Subnet, you have the likes of Polkadot using the Parachains model if you are building with Substrate. And then we'll have the Pairwise Bridges. So Pairwise Bridges, in this we're talking about normal bridges like Hop Protocol, Axelar Network, and the rest of them. And then we'll also talk about wrapped assets. So let's say, for example, you take BTC, we'll have WBTC, or we'll have Rain BTC. But these have some engineering flaws, and it takes a lot of time to engineer these things. There could be some bugs in the smart contracts. And imagine, for example, you have to create a code for, let's say you want to bridge 1,000 assets, meaning you have to create 1,000 different pieces of code to just bridge this asset. So it's a pain to these engineering people. So you might be asking a simple question: what has been the problem so far? How do you design a system where you can bridge everything together? There are certain properties that must be adopted. One of them is the plug and play integration. So what that means is that if I am building an application and I want to bridge assets to my application, it should be very easy. I don't have to do a lot of engineering work. It should be with minimal effort. And then how do you discover addresses? Because the addresses on BTC are not the same as the addresses on Ethereum, and they're not the same as the addresses on here and the rest of them. So how do you discover this kind of thing? You know, the internet was a problem until they had to agree on certain protocols on how do you the HTTPS, hypertext transfer protocols, and also with email. So how do you have Gmail, for example? How do you send messages from Gmail to Yahoo and back and forth? So there has to be a way where we route information, and how do you discover addresses? Then there has to be upgradability support. So it should not be, for example, this is a blockchain, this is a blockchain, this is a blockchain. When you want to make some upgrade, it should not affect the whole system, right? And there has to be a uniform language. Blockchains have to have a kind of uniform language, and that they're communicating through a language or some APIs. And then you might be asking questions. Okay, one of the challenges with this stuff is security guarantees. Like the assumptions, it's not going to be one chain rule and more. There's going to be multiple chains. We have the likes of Ethereum gaining traction, Avalanche, Solana. So it's going to be a multi-chain future. So having a multi-chain future, there is a need for cross-chain. So if you are dealing with cross-chain, you want to talk about security assumptions. And we don't trust. So there has to be decentralized trust. You're not going to tell us and say, oh, the asset on our chain is secure. How do we verify that it's secure? It has to be decentralized. And then there has to be a high safety. And then there has to be high liveness. We don't want, oh, the system is down, you cannot access it, and all sort of bullshit. So how do you design something that is open chain? So there has to be open membership. Anybody, anywhere, at any time can join as a member. And then updates to membership, I can decide to leave anytime I want. There should be the right incentives. BTC was not really a special system, right? We were talking about the likes of normal consensus, classical consensus, using proof of work and the rest of them. When there is certain theory in place, that is where you talk about Bitcoin. So Bitcoin was not something special. Then there has to be a consensus. How do we agree on the system? And then how do you manage keys? Somebody leaves the system, do we revoke their keys and all that? So let's talk about Axelar. So Axelar consists of a network, a set of APIs, protocols, and a host of other things. So as a network, it's a delegated proof of stake network. So meaning they have some delegates, and these delegates, they are people who will stake on their behalf and validate transactions. And one of the things I really want you to understand is that it has two protocols. We have the cross-chain gateway protocol that ensures state synchronization. So what that means is that validators on this network will basically run what they call light clients. So you run light clients. So the light client is basically saying, I'm trying to keep information about what is going on in a particular chain. And when we are saying, tell us what is happening in chain A, you can easily tell us what is happening in chain A, and you are aware and post information. And then easily asset transfer, we can easily transfer assets from one chain to another using this protocol. And then when you're designing this system, there has to be maximum security. So we have some assumptions. We have maximum safety, maximum decentralization. It should be decentralized, everybody should come in. Then there has to be maximum robust fallback mechanism. So what that means, we're actually talking about a system, in case anything goes wrong in a system, how do you sort out this? Are you going to pause the network for some time or another? And then the benefits, if you are building blockchains, you don't have to worry about interoperability. If you are building apps, you don't have to worry about interoperability, and for end users, you can easily connect. So the issue of interoperability is solved. Thank you.